Hello, boys and girls. This is lesson 3.8, ordered pairs relationships. So today we're going to be talking about finding relationships between ordered pairs on a coordinate plane. Remember, a coordinate plane is, let's see, there it goes, is the quadrant. There's my little drawing. An ordered pair is the two numbers that represent the x and y axis. For example, 3 and -2. 5 and 4, -6, -7, etc. -2.8 and -3.4. You get it. So today we're going to be looking at relationships between ordered pairs, and we're going to be learning about the quadrant. So here I have a coordinate plane for you, or coordinate grid. They mean the same thing. And you'll notice that it's two number lines put together. It's a horizontal number line, 0 being at the center, positive going to the right, negative going to the left. And it also is a vertical number line, making kind of a plus sign. Positive numbers going from the middle to the top, negative numbers going from the middle to the bottom. Now when we look, you notice that we have 4 quadrants is the word that we're looking for. And so here's 1, 2, 3, and 4. Now these 4 quadrants have names. Now they're named quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So they're not that fancy at names. But quadrant 1 is always this one here. And then we go counterclockwise. 1, 2, 3, 4. Now you'll notice a pattern. All of the ordered pairs, which are these things, and quadrant 1 will always be a positive positive. So if you notice over here, I gave you kind of a little answer key. Positives are red, negatives are blue, okay? So quadrant 1 is a red, pause. So let me go ahead and write. Pause. Always. If both numbers are positive, it'll be in quadrant 1. Now, quadrant 2, this one here, is a negative positive. So it is, oops, I'll switch back to black, sorry. It's a neg pos. And I tried to do it color coordinated, so you have a blue Q, and the numbers are red there. So it's negative positive. Quadrant 3, down here in the bottom corner, the opposite of quadrant 1, is a neg. Both are negative. And then the final quadrant, quadrant 4, just below quadrant 1, is a posneg. And so when you find an ordered pair, you can place it in the right quadrant. So let me give you an example. That's a really long example. But if you notice down here, we'll go through this in just a minute. It's from the Go Math book. I forgot what I put on this page. If you notice down here, we have our little coordinate plane. We have quadrant 1. They always write them in these little Roman numerals. Quadrant 2, quadrant 3, and quadrant 4. Remember, pause, neg, pause, neg, pause, neg. Okay, so let's look up here. You can do this in your Go Math book, or you can write down the coordinate grid, the problem, and then the answer and how you got it. The point -3, 4 represents the location of a bookstore on a map. Pretty cool. Sorry, my laser went away. On a bookstore on a map on a shopping mall. Identify the quadrant where the point is located. So here, I'm going to highlight what we need to do. We just need to identify the quadrant. That's all. We just have to say, is it quadrant 1, quadrant 2, quadrant 3, or quadrant 4? So we really only have 4 options. We could guess, but let's try to actually solve it correctly. So the first step when we're finding the quadrant is we want to look at the x-coordinate. Now remember, x is first, y is second. So our x-coordinate is -3. So we're thinking the x-coordinate is negative. So the point is 3 units to the which direction of the origin? Negative would go this way. So 3 to the left. Okay. Since the quadrant or the point is to the left of the origin, it must be located in either quadrant 2, or 3. We're not done yet. We've just narrowed it down. We now know that it's not quadrant 1 or 4. So now we could guess, but let's keep trying to figure it out. Now we're going to look at the y coordinate. Let me switch colors here. Let's go green. So our y coordinate is positive 4. It is positive. So the point is 4 units to the right. Oops, sorry. This is the y coordinate, so it's going up and down. It is 4 units. Positive would be above. That kind of is a weird sentence. 4 units above the origin. Since the point is above the origin, it must be located in quadrant 2. Yeah. Because it's, sorry. Since it's above the origin, so we already knew it was either 2 or 3, and since it's above the origin, it's going to be in this quadrant up here. Okay, that's how I figured that out. So the point representing the bookstore at -3, 4 will be in quadrant 2. And I'm doing, instead of doing the number 2, which you can do, they usually represent it by Roman numerals, which is just 2 straight lines. Okay. So that's how we found the quadrant for -3, 4. Now, if you just wanted to graph it on the graph, you could. Totally fine. If you wanted to think pause, pause, neg, neg, pause, neg, you could. All right. So take a little time to pause in your math notebook, or you can just type it into the Chromebook. And I want you to notice, look at the signs, the coordinates of the points in quadrant 1 and 2. So looking at these quadrants, 1 and 2, what do they have in common? And how are they different? Go ahead and write that into your Chromebook. So one thing that I noticed that they had in common is that both of them have positive y's. Y coordinates. They both have positive y coordinates, and I think that's because, and actually I know it's because, this number line here is positive, and they're both positive y. So that's what I noticed. How they're different, their x-axis is different. And I think, well, I know that that's because here they're split positive on this side and negative on that side. So they have different, let's say, opposite x coordinates. All right, let's do some try it problems. So all you have to do is tell me which quadrant this ordered pair is. So -7 and 3. So looking at -7, x, and this is the example, so then you can try it. I know that -7 is going to be this direction. So it'll be either in quadrant 2 or 3. Then I look at +3. +3 would be this direction. So I know it's going to be in quadrant 2. Okay, go ahead and try the example problems on your own. All right. So let's see if I can erase these. See if that'll work. Yeah. So to check your work here. So 8 is our first x coordinate. So we're going to go across. And if we go across to the right, positive. And then our y coordinate is +8 as well, so we go up, positive. So this would be located in quadrant 1. And finally, let's do this last one here. So this would be quadrant, x would be positive, so quadrant 1 or 4. And then it looks like the y is negative, so we would come down to quadrant 4. And that's IV, which means 4. Okay? All right. So here, we're going to so we were just talking about which quadrant those ordered pairs go into, and now we're going to be talking a little bit about the line of symmetry. You've probably done line of symmetry before, so just to review, if you have a shape and it has line symmetry, it means you can draw a line on it, and when you fold it in half, it's the exact same. So I just have some different pictures here, and I can draw on some of them, not all of them. I can draw a line of symmetry through them. So for example, on this triangle, I should be able to draw a line of symmetry straight down. Folded in half, it would be the same shape either direction. But this would not be an example of a line of symmetry. If I folded it here, it would not fold perfectly. So that would be a counterexample. So let's show you on this one. There is a line of symmetry on this arrow here. If I was to cut it, oops, that was really crooked there. Sorry, I got a new stylus. It's giving me some issues. So that would be if I went straight down and I was perfect. It would be a line of symmetry. If I went across this way, though, that one's not a line of symmetry. Nope, doesn't count. Let's see. On the heart, we could go this way. We could not go across this way, though. That wouldn't work. The star, we could go if we went straight through the top. And if it was perfect, I drew the star, so it's not perfect. And then the circle, you can cut that line anyway. It would be a perfect line of symmetry if it was a perfect circle. Okay, so how does that relate to what we're doing with coordinate plane? So we want to find the line of symmetry, oops, sorry, that was the wrong button, in the rectangle. So looking at our coordinate plane, you see our rectangle. There's 4 points. Now these points where that letter is right there, that's just the name of this point. So A, which is at 5, 4, that's point A. This is point B, point C, and point D. So what we want to do is identify the lines of symmetry in the rectangle. So the x-axis is a horizontal line of symmetry, and the y-axis is a vertical line of symmetry. We can go ahead and fill that in. I don't like filling these in because sometimes I think they're a little confusing, but we can do that. Look at the points A and B. This is where I am. Sorry, I'll get the laser. Look at the points A and B. Doop, doop. What do you notice about the x-coordinates? What do you notice about the y-coordinates? So looking at A, I've got positive 5, positive 4. Looking at B, I've got positive 5, negative 4. Interesting. I noticed, so I'm going to write this. See how small I can write. I notice x-coordinates are the same. Coordinates are the same. And I'm going to use my vocabulary word from earlier in this chapter and use opposites. The y-coordinates and y-coordinates, oh my gosh, it's a long word, are opposites. Okay, let's keep going. Point B is a reflection. So think of a mirror. It reflects point A across which axis? So point A and B, which axis or number line is between point A and B? Which number line do I cross? I'm crossing the x-axis here. So it is a reflection across the x-axis. And I know this because it crosses through them. The x-axis, because it crosses through. Now I also notice that the x-axis, or the x-coordinate, was the same. Remember, our x-coordinate was the same? So I'm noticing that. That's a pattern I want to notice. Let's do the next part. Now we're going to look at points A and D. what do you notice about the x coordinate? What do you notice about the y? So A is 5, 4. D is -5, positive 4. So our first number, x coordinates are opposites. Our y coordinates are the same. And I'm going to shorten this. X core is opposite. Oh my goodness, let's try this. Y core is the same. And so point D reflects point A across the y-axis because their coordinates were the same. That's supposed to say the same. So again, we're looking just real fast here. So A, when we had A and B, we were going across the x-axis, and A and D are reflecting across the y-axis. If we folded it in half, A would line up perfectly with point D. If we folded it in half hamburger ways, A would line up perfectly with B. Okay, so moving on. So we're looking at, this would be a level 2, maybe 2.5 question. The 2 points are reflections of each other across the x or y axis. Which one is it? So I put a little coordinate grid here for you that you can look at. It doesn't go far enough, but you should be able to get the main idea. So -9 and -10, I'm going to do this. I'm going to say, well, what quadrant is -9 and -10? I know that it would be, let's see, -9, and this one's the example problem. -9 would be going this direction. -10 would go here. So point A, my first point would be in quadrant 4. Point B would be -9. I'm going to just go over this again. And +10. So if I've drawn this perfectly, point B would be up here, point A would be down here, and it would reflect over the x-axis. Because that's this axis right here. So go ahead and try the next two on your own. Okay, so number 16. I am just taking so long in this video. I'm so sorry, guys. It's taking me a while. Positive. I'm going to do first point. They're not numbered, so it's going to be difficult for me. Would be positive and negative. So that's going to be in quadrant 4. And then second point would be positive. So it'd be in quadrant 1. So it looks like our points line up on the x-axis again. And the second one, sorry, I'm getting a little frustrated with my stylus. This new one's giving me trouble. Okay, we would be positive, negative for point 1, and point 2 would be negative, negative. See how they both matched up here on this y-axis, and so it's on the y-axis. If you did it a different way, totally fine. That was one strategy that I used. You can do it another way. Alright, so here they're telling you the point, and you want to tell them what the other point would be if it was reflected across the y-axis. So I'm going to do the example problem. So -7, -7. If I was to plot that point, it would be, doesn't quite fit here, but I would say it's right about here in quadrant 3. And so the opposite on the y-axis, I'm going to look at my y-axis, and it's going to be going that direction. It would be over here, and that would be, looking at this here, +7, -7. Go ahead and try number 19 on your own. Okay, so for number 19, I don't know why it has that random number on it. That's cool. So we would do negative 15 would be in quadrant right here, be somewhere over here, negative 15, negative 18, and they wanted us to reflect across the x-axis, so we'd come down here, and that would give me a negative, negative, negative 15, negative 18. And another way you could look at it is say, well, if I'm reflecting across the x-axis, I want my x's to be the same sign and my y's to be opposites. Just like on this one, we wanted our y's to be the same sign, our x's to be opposites. Alright, this last try it problem, I want you to pause your video, try it on your own, and then I'm just going to have the answers on after. So go ahead and pause now. So here's the answers. I just gave them all each a letter, and then that's how I sorted them. Just so you know, there was one just like this on the benchmark last year, and possibly on Sage. I can't remember, but I know that there was one just like it on the benchmark. So it's a very common 6th grade standard. All right, boys and girls, that's all for today. Sorry for the long video. Hope you have a great day learning.